Good morning, everybody. Welcome again to AtlanTec Festival 2021. My name is Seamus Hayes. I work for Genesis, and as a member of the AtlanTec committee, I'm delighted to be here as your event moderator today. So today is day 4 of our AtlanTec Virtual Festival. There have been some really insightful and thought-provoking presentations and discussions over the past 3 days, and there's still lots of fantastic speakers to come. This is our 7th year running this festival. It's the second one, unfortunately, that we've had to run virtually. Hopefully we'll all be back in person next year. Over the 5 days, we'll have over 40 events and 60 different speakers. We really appreciate you all taking time out of your busy day to join us, so thank you. And we'd also encourage you to participate and to get involved. You can follow us on Twitter. Our handle is @AtlanTecFest, and don't forget to use the hashtag AtlanTec. Throughout this presentation and all the presentations, you can use the Q&A function to tell us why this topic is of interest of you, and also obviously to get all your questions and feedback. We're all about what's of interest to our tech community of innovators and practitioners along Ireland's western seaboard, what we call the AtlanTec Gateway. These events are supported by the tech community, enabling the sharing of expertise and knowledge. AtlanTec 2021 is again being run as a free event this year, and we are very grateful to all our sponsors who have helped to make this festival a reality. We really appreciate all your continued support. So just before I introduce Ian, I would like to remind you all that I will be tracking all your questions throughout the presentation. So again, you can use the Q&A function. So on the bottom right-hand corner, you'll see an icon with 3 dots, a button with 3 dots. And from there, you can access the Q&A function and we'll get all your questions to Ian as he goes through his session. So with that, it is my great pleasure to introduce Dr. Ian McLoughlin. Ian is a lecturer at the Department of Computer Science and Applied Physics at the Galway Mayo Institute of Technology in Ireland, where he teaches modules in emerging technologies, data analytics, and mathematics. In 2018, he received the GMIT President's Award for Teaching Excellence, while in 2014, he was a Fulbright Tech Impact Scholar at Stanford University in California. He previously has held positions at the Institute of Technology in Sligo, the National University of Ireland in Galway, and University College Dublin, and has worked in industry at the Aon Centre for Innovation and Analytics in Dublin and at the IBM Research Centre in Zurich, Switzerland. He holds a PhD in mathematics from the National University of Ireland for Galway and was awarded an Irish Research Council scholarship in 2005. So with that, it's my great pleasure to hand you over to Ian.
Thanks a million, Seamus. Can you hear me okay?
I hear you perfectly, thank you.
Great, thanks a million. So thanks, Seamus, and thanks, William and Ian and everybody organising the AtlanTec conference, and thanks everybody for coming along today to the talk. So as Seamus said, I'm Ian McLoughlin. I'm a lecturer at GMIT in the Department of Computer Science and Applied Physics. And I'm going to talk to you a little bit about some work I've been doing recently with some SMEs in, I guess, the data analytics research space. As a lecturer, I typically have students on who come in and they learn how to use computers. So they're computing students. We teach a software development, a bachelor's in software development, a higher diploma in data analytics. And those students see themselves as computing students. On the research side, I typically work on sort of the applied research side. So I'm working with companies that don't necessarily think of themselves as ICT companies. And I just want to highlight in the talk today kind of an emerging idea that I see as a lecturer, which is that there's a new cohort of companies, of people out there who are very tech savvy, but don't necessarily think of themselves as ICT people, as computing people. And I've been working with some of those who have set up small businesses, and I think this is going to become a more important sort of facet of the economy in the future, and will have implications for what we do at third level in the provision of programs, but also in the provision of research, particularly applied research with industry. Okay, so the first question you probably have is, who's this guy? So let me sec, there we go. So let me just give you a quick overview of my background, because I think it's relevant to the talk. So as Seamus said, I have a PhD in mathematics from NUIG, which is funded by URCSAT. My undergraduate is also from NUIG, and that was sort of in a program that was halfway between mathematics and computing. in between my undergrad and my PhD, I was at IBM Research in Zurich in Switzerland, where again, we were working on quite in-depth computing ideas, building web applications, looking at data streams and all that sort of computing stuff. After my PhD then, I worked at the Aon Centre for Innovation and Analytics, which was kind of a startup within Aon. Aon's a huge multinational insurance broker. So Aon has clients who are looking for insurance and, big corporate insurance policies for directors and officers and all of that sort of stuff. So at the Aon Centre for Innovation and Analytics, we used to pull in a load of data from all the different components of Aon, analyze it and see if there were any insights in there. After Aon, I went on and did my postdocs it was actually a collaboration between UCD and NUI Galway. I was a postdoc at each of those for the same project at different points. And that was actually funded by an Enterprise Ireland Commercialisation Fund project. So that was very interesting, but again, very computing focused. And then I moved to IT Sligo, to GMIT, and in between I was at Stanford for a few months on a Fulbright scholarship, as Seamus alluded to. And I think a lot, when I applied for my Fulbright scholarship, I told them all of the ways I would tell people about what I was doing at Stanford and how I'd disseminate all the work, all the insights that I gained and all of that. So I guess I should talk a little bit about that, but I'll try to keep it to a minimum. But I mean, I do think a lot about with Stanford, like why is Stanford Stanford? Stanford regularly comes out at the top, top 2 or 3 positions in the university rankings, if you believe those, right? And one of the things I wanted to do when I was at Stanford is go around and ask people, particularly people I was working with, like, what makes Stanford Stanford? And invariably, people would come back and say, look, we do lots of interesting research, and there's very good researchers here. But actually what we've managed to do is, we've spun out or in some way had associated with us companies, computing companies primarily, that have had huge commercial success. And they tend to, send more people our way, but also send a lot of money our way. They tend to come back and build buildings for us and invest heavily in Stanford University. And I think about that a lot because when we think about the kind of research we do as academics, sometimes in Ireland, we get very focused on funding and papers and all of this sort of stuff. And, we always throw out stuff about collaboration and, multidisciplinary stuff. But it's interesting to see that what the take that I got from Stanford was that people thought Stanford was Stanford in to some degree because of the tangible outputs of the research, more so than the papers and the funding and all of that sort of stuff. And I'm particularly interested in that myself, although I'll try and keep it to a minimum in the talk, because I'm a member of an advisory group to the Department of Further and Higher Education Research and Innovation in Science in high performance computing that's just been set up. And I'm also a member of Academic Council at GMIT, where I'm involved in program development and validation of programs and trying to look at, I suppose, academic strategy whenever we get around to it, because of all the other work that we do. But so I'm really, really interested in what's going to happen in the future. So the idea of working with SMEs came to me largely because of the work that I'd done in all of these other in all of these other institutes and companies. Sort of it almost came by accident, but it makes perfect sense now. So I mean, let me just take a step back for a second and see here. See if I can move on to another slide. There we go. So just as a heads up, I'm going to be talking a lot about research with SMEs and what my role in those projects is. And it's hard to describe what my role is, but I think that the connection is that really companies are looking for mathematics, but they don't really know that they're looking for mathematics. They often won't say it like that. They'll say they want something computing, or they want something, data analytical, or something along those lines. And in fairness, I've seen, society at large grapple the term mathematics, regularly you'll hear about it in the news, you'll hear politicians talking about it. Invariably, you'll say that, you'll hear big multinationals looking for more STEM skills, as they would call them. But I always think, it's unfortunate that the M is at the end of STEM, because I do think sometimes when people talk about STEM, and if you look at the policy that academic institutes drive sometimes, they heavily focus on what they consider the S of STEM, which is, science. So most people will think of the physical sciences, like physics, chemistry, and biology. And obviously, I mean, in the midst of a pandemic, particularly biology is very, very important. But I think like the M gets less money, and maybe it's just because it's at the end of STEM, I don't know. But that said, I mean, the difficulty here is that it's actually it's really difficult to describe what mathematics is in the first place, So there's a great book that I read many years ago called Maths You Can't Use. It's by a guy called Ben Clemens. And in that, he talks about patents related to, he was talking about software patents, but actually he kind of focused in on the mathematics side of it and said, like, well, this is what, the mathematics behind the situation is actually what we're talking about trying to patent here. And he gave the common example of the bridges at Königsberg, which is an old mathematical problem. It's an old city. It's called, I think, Kaliningrad now or something like that. But there's a city in Europe / Russia, and there's 4 different parts to the city. And back in the day, 200 years ago, 4 different parts of the city were connected by a series of 7 different bridges. I'm sure some people in the audience will know this problem well. So you can represent, just like I have here in a little diagram, you could represent the problem as a series of dots and lines, where the dots are, each of the parts of the city, 4 distinct parts that were separated by rivers. And you had these 7 bridges connecting the different parts. So there were 2 or 3 bridges sometimes, 2 bridges between certain parts of the city. And there was this open question as to whether it was possible to walk around each part of the city, crossing every bridge exactly once. And it was just a game that the people in the city used to play, and it was kind of an ongoing question, and it was just a bit of fun. Eventually, a famous mathematician called Euler, he came in and he actually showed this is impossible, right? He could come up with some logical argument surrounding the number of lines that you had in this diagram and the points, and he said, okay, look, here's a logical deductive process that says you can't do it. And Ben Clemens's point in the book is, when you describe that problem to somebody, you only need to use words. You don't need to use equations or any mathematical notation or plots or anything like that. And yet there is no doubt that this is a mathematical problem. Okay, so it's clear that the bridges of Königsberg is a mathematical problem, and not least because one of the most famous mathematicians in history solved the problem originally. So I think about this a lot, because when I try to describe what my role is in research projects, this is kind of what I'm getting at. It's, that mathematical basis for what you're trying to provide to an SME or anybody that you might be collaborating with. I don't just work with SMEs, I also work with other research groups and, help them from a maths or statistics point of view with their projects. And when I try to describe my role, or sometimes I get the question, like, what's in this for you? It can be difficult to describe. And I often think of this problem in Ben Clemens's book, where I think maybe it's too difficult to describe what mathematics is, but this is what companies are looking for. Okay, so with the you guys aren't scrolling along for me. Just give me a second now. Sorry, I just don't know why it's not flicking along for me. There we go. Okay, so that's the kind of service that I think I'm providing in different research projects. So here's the central theme of the talk. It's that there are small companies interested in research. Now, this is true and has been true for a long time. I don't doubt that. But there's a certain cohort of companies that I see, which I think is new, where the companies are not computing companies, as I said. They're not looking to develop necessarily a web application or a mobile application or some new platform or some cool, DevOps provision or whatever. So they're not computing companies, but they are tech savvy, and that's the difference. Okay, so they are usually typically very comfortable with Excel themselves. Okay, and I don't mean just like moving data around Excel and copying and pasting and looking at it and maybe doing the odd plot. Like, they're really good at Excel. They can really make it sing. And they've probably dabbled beyond Excel. Okay, so they might have looked at a little bit of programming. They know about different technologies that are out there, but they're trying to grapple with them. So I've done about, I think, the last count, 12 of these small projects with these companies from lots of different sectors. There's, wind energy companies, but also marketing companies, economics consultancies, 3D printing companies, lots of different sectors of the economy. But the one thing is that they're all fairly tech savvy. So the projects are typically funded by Enterprise Ireland, although I have done one with Invest NI, which is, the Northern Irish counterpart to Enterprise Ireland. They typically have a budget of about €5,000, and Enterprise Ireland basically give that €5,000, not in cash, but in the form of a voucher to any SME. You have to meet the criteria or whatever, but they're fairly loose. They go on the website, apply, fill out a quick form, takes about 10-15 minutes. And then Enterprise Ireland reviews it and says, okay, that looks reasonable. You can have a voucher. So they give you, it used to literally be a piece of paper, but now it's obviously digital PDF form, whatever. And they can then go to a third level or a higher education provider looking for whatever little bit of research they need done. And they can shop around a little bit, talk to lots of different people. So we get a number of people, every year coming to GMIT with these vouchers. And we have to, on the one hand, we like doing them. It's good to do research. It shows that we're having an impact. At the same time, we have to be careful, to make sure that that we can provide what the company is looking for, but also that the problem is well defined enough that we can actually we can do something proper with it. And I guess like the other side to it is that we need to be sure that the company understands that in a €5,000 research project, what you're going to get out of it is probably a report and a rough research prototype. So that might be a Python script or some sort of small program. But it's important that the company realizes that, they're not going to get a fully fledged product out of these innovation vouchers. So they're very small in the grand scheme of things. These are small research projects. So I think, again, my mouse is not, hang on a sec now, sorry. I don't know why my mouse will not click me on. There we go. Okay. So just alongside that, that's one way that companies have been coming to us with these innovation vouchers, and I'm seeing this new cohort of companies that are tech savvy, but not necessarily computing companies. We have another inkling that there's more companies like this out there, because at GMIT we set up a higher diploma in data analytics a number of years ago. Now these are all over the place now. I'm external examiner for one in Dublin, and a similar course, a master's in CIT and artificial intelligence, which is quite similar to master's or higher diploma in data analytics in practice. But anyway, a number of years ago we set up our higher diploma in data analytics, and it's a little bit different because it's a 2-year part-time predominantly program, and it's focused on people in employment. It's been funded by Springboard, which was originally a a mechanism that the government had to retrain people who are unemployed. But a couple of sectors of the economy, one of which is ICT, the government said, actually, look, you can provide programs through this Springboard initiative where students won't really have to pay fees. You can provide that to people who are in employment as long as they're in, ICT, or I think there's another one in nursing or something like that. So we have this higher diploma in data analytics. When we originally set it up, like I always had in my mind, I've got a few little people in orange, green, and blue here. I always had in mind the work I used to do in Aon. When I was in Aon, I had just come out of my PhD, and I thought, I was going into a big insurance company, that I was going to learn all about finance and how insurance worked. And, you know, I'd be learning a lot when I went in there, but I quickly, I suppose I was a bit naive coming out of my PhD. When I went in there, I quickly realized, like, I was supposed to be some sort of an expert in, data and mathematical techniques and all of that, which makes sense when you think about I had a PhD. Um, but then I kind of realized, I thought there'd be loads of people like me in there, but actually there were many more people who would have considered themselves, probably had the title data analyst or something like that, who actually did the main bulk of the work that we were trying to do in Aon, which was pulling in all of this data from around the world, from Aon's databases, which was obviously, often heterogeneous. Like, it was all insurance data, but different countries would have different laws relating to the type of data you had to collect for your insurance policies. And I should say, like, this was all, commercial data. There was no personal insurance policies here or anything like that. And anyway, it was the days before GDPR. Um, so I realized there was kind of like three cohorts of people in Aon. There were very few of me. I don't know what I was. I have myself in orange here, some sort of artist with, some sort of degree or something like that. I don't know. I mean, I was kind of a mathematician, is what I would have said I was. I was hired. My job title was technically statistician, which I often think would give people a good laugh who were in college with me, because I didn't do much statistics in college. Um, but I did have a heavy mathematical and computing background. So there was one me, and when I went in there, as I said, I thought there was going to be loads of me in there, but there weren't. There were many more sort of data analysts who, I guess what I was doing was modeling. I was coming up with mathematical models, machine learning models. Really, I was trying to pull people out of Excel. I'd kind of say, you're trying to do that in Excel. It's a semi sort of manual process, at least, if not a fully manual process. Maybe we could look at automating that process, and I'd try and pull them into, try to pull them away from MATLAB if I could, and into Python or whatever. But then there were many more people who were these data analysts. So they would take those Python scripts, and maybe there would be a little bit of like communication and education that would, I'd have to help them. But eventually the people in green here, the data analysts, would be able to take what I was doing and sort of, I guess, productionize it in a way, make it a bit more robust, and run it themselves then in future if it was a task that needs to be run every day, some sort of report or, whatever. That they could take it and do that. So there were many of those. They were separate to the guys in blue here. I have guys in blue here who would typically think of themselves as kind of the IT team. In Aon, we had two different kind of groups here. We had the people who were managing the infrastructure in terms of the physical infrastructure in our own building, which was the computers and maybe the odd server and the network and all of that sort of stuff. So I have them with the headpiece there. There was also a gang of people who considered themselves IT people who were building, like, the main output that we had as a company was this web application dashboard displaying insurance information. And so I'm mixing them in together, but actually there were two separate teams. Another reason I think about this a lot is because, I mean, in higher education, sometimes I don't know if we've distinguished all of these four types of roles. If you look at the programs that we provide, we provide undergrads in software development and digital media, but mathematics departments provide mathematics courses. Computer science departments might provide obviously computer science programs, but I'm not sure, like, if you want to be any one of these people in orange, green, or blue, you're probably going to be told coming out of school to go in and do computer science or go in and do some sort of mathematics or whatever. But maybe those programs aren't specific enough. They're not delineating between all of these different roles. So I think computer science actually these days is not just one subject, and I think about that a lot. But in any case, this gave rise to the higher diploma in data analytics. I was looking to target the people in green here when I was thinking about developing the higher diploma in data analytics with the others. And it was surprising when we actually ran it. We got a slightly different cohort of students than I had imagined. I'd imagined people who were fairly young, maybe had, higher diploma go on a higher diploma, you typically need to already have a degree in a different discipline. So if you want to do the higher diploma in data analytics, you might have a primary, a level 8 honors bachelor in some other type of science, right? So physics or chemistry or something like that. So they're the type of people I imagine would come on this. But we got a huge cohort of people. I mean, two types. We got really high level managers and executives in companies and public sector bodies. Now, when I say a huge number, we're admitting about 80 people. We've admitted about 80 people, up to 100 people every year for the past 4 years onto this program. And, maybe 10 to 15 of them are high level in different companies. So that surprised me. We even got some, people from other higher education providers, which I thought was really interesting coming on it. But then we got this cohort of students, again, maybe 10 to 15 out of the 80, that were involved in or owned SMEs, small to medium enterprises, that weren't computing, companies, which, if you think about the fact that they were coming in with a degree from some other discipline, that makes sense, right? Because, if their background was, engineering or something like that, civil engineering, let's say, they were coming onto the higher diploma to try and gain some computing skills here. So there was this cohort of students who came in, who were involved in SMEs, which I thought was really interesting and kind of gave rise to some of the research. We've done some collaborations with some of the graduates of that higher diploma now, because we've had a I think one cohort graduate already, if not two. Okay, so just on then the point on talking to companies about doing these small research projects with them. So as I said, these are Enterprise Ireland funded projects, very small, €5,000. So we often, I said I've personally done about 11 or 12 of these, and in GMIT we've done many more over the past several years. We've also turned, I don't want to say turned away really, but we've also sort of had discussions with other companies who we haven't proceeded with, or they haven't proceeded with us. And when I try to classify in my head the companies that we do end up working with versus the ones that we don't, I think about the companies that the companies we do end up working with usually come with a well-defined problem. They've been teasing something out themselves. They've started in Excel. They saw something in their company and said, hang on a second, I need to get a handle on, a data source. So a typical example we would have is the small wind farms, small energy producers who are trying to compete with the big energy producers. So there might be only 4 or 5 people operations, and they're getting all this data out of their wind turbines, and they have to sell it into the electricity market. You have to sell electricity ahead of time in the island of Ireland. So they need to try and come up with a good model for predicting the output of a wind turbine tomorrow, where you don't know what the weather's going to be like. You don't know if there's going to be wind. So you need to get weather forecast data. And maybe you also need to get, data from the turbine. You need to know for a given wind speed, how much electricity the turbine is going to produce and all of that. So those companies came with really well-defined problems to us. And we said, yeah, we can help you with that. A typical example of another company that we haven't ended up working with would be somebody who comes along and says, the first thing they say to you is, look, I know nothing about technology, but what I want to do is develop a web application for the services industry, or, for restaurants or something like that. And, immediately, like within 5 minutes talking to the people, you're not going to do the innovation voucher, because effectively what that company is saying to you is, they don't think of it like this, but from my point of view, I'm like, you're saying you want to become a technology company, you want to become a computing company, you want to manage and run a web application. It doesn't matter what other sector it's applied to, whether it's restaurants or whatever it is. You're planning on running a web application, and you do not realize that there's a whole industry out there called DevOps that you're going to have to grapple with. And if you're immediately saying you don't like technology, it's a bad idea to try to become a technology company. So I would think of those companies as companies that have ideas, but they're not formed well enough. They haven't been condensed down into problems. And I think if you went back 10 years ago, most of the SMEs that were coming with innovation vouchers really just had ideas. Whereas the new thing these days is that I think the companies that I'm seeing and that I'm targeting in my research now are the ones that have fully fledged problems, because they've been able to take out the problem, go back to the wind turbines, they can take out the data of the wind turbine. They're happy enough to get their hands dirty in Excel and chop and change the data, and they've a little bit of insight into the mathematical basis for things, particularly if they come from an engineering background or whatever. And but they don't have the last piece. They don't know how to connect all the dots and put it all together and turn it into a nice little package. Okay, so just by the by, on the ideas front, sometimes I feel like one of the research projects from history that I think a lot about is the atomic bomb project, okay, which is a bit weird, I guess, but it was, the birth of computing, or modern computing at least, and also, quantum mechanics, I guess, in a way, which is going to be interesting from a quantum computing point of view. So there's a guy here in the middle, just beside Oppenheimer there. He's the one looking down at some sort of sheet in a white shirt there in the middle of the picture. That's a guy called Richard Feynman, and he's a very famous physicist, only died, not too long ago. He worked in the atomic bomb project, and he has some great writings about, the type of research you should do and how to do it. And he said the first principle is that you must not fool yourself, and you are the easiest person to fool. And I think a bit about the people who are coming with ideas where they might have a successful business in another sector of the economy, and then they hear about all this technology and they want to be tech people, with a really cool web application or a cool mobile app or whatever. But I just think about that a lot, in terms of research policy and what I should do myself as an academic when it comes to research. What I like about the atomic bomb project is, it's a big research project, obviously, but it had a really tangible output. Obviously, it was a devastating bomb that was created, but they weren't caught up on writing big long research papers or attracting research funding, although in fairness some people would have been, like Oppenheimer there. But there was a tangible output from that research in the form of a bomb. And I think about that when I'm, aside from the people who are coming to us with ideas, when I think about the people coming to us with problems, clearly defined problems, what I find interesting with SMEs is that they really need it to work. The stakes are higher for an SME than projects I've done with bigger companies. Bigger companies are interested in doing research and development just to do research and development. And there are many different incentives that a big company might have. They might be looking for funding themselves from government bodies or whatever. So they're interested in just doing research and development. And if things don't work out, it's not as big a deal. And many SMEs have that approach too. But generally speaking, I would say the SME is coming to you with a problem and they need to know whether it's going to work or not. Interestingly, they are very open to the idea that they want to know if the thing isn't going to work. So a couple of projects I've investigated it and gone back to the company and said, actually, look, here's 3 or 4 research articles of people trying to do this in the past that I found, and it's not that it's not going to work someday. We're about 10 or 15 years off this thing working. And by the way, Google and Facebook are already working on it. So, while that's, you get a little bit of trepidation talking to them, come back with that, I found SMEs very receptive to that idea, and it's good. They usually thank you for that sort of information because they're like, okay, we need to park this now and move on to something else. So just quickly, I'll try and be quick about this. There's two preconceptions that I want to talk about. So one is the preconception from the academic side coming into these small research projects. I hear a lot about, I'm involved in a couple of big projects now and all of these small projects. I hear a lot about, any research office will tell you, most of the people in there will say, I'd much rather one big project than 5 small ones, let's say. So on the, if you look at, oops, sorry, now it's going ahead of me. If you look at the innovation vouchers, the small projects that I'm working on, typically they're 1-person projects. Usually I'm the only person working on them. And obviously I have to interact with the company, but that's fine. So if you imagine the small research projects that I'm talking about in green here, and just I've got aliens and all that sort of stuff, but there's one person on each of these projects. First is a bigger project that you might have in blue, where you might have 5 people working on the project. So you might get a couple of PhD students or a research fellow or a postdoc or whatever. The the preconception we have as academics sometimes is that bigger is always going to be better because you will get economies of scale. But that actually hasn't really been my experience. The bigger research projects tend to come with so much overhead. In terms of, like, even if you look at the number of meetings you can have in the blue circle here, with 5 people, you can have 1 5-person meeting. You can have 5 4-person meetings. I think you can have 10 3-person meetings, 10 2-person meetings, and the mathematician in me wants to say, and 5 1-person meetings, and of course the empty meeting, but ignore those. Even still, there's a huge number of meetings you can have in the blue circle, and that's before you even talk to any external party like the company that you're working with. So it's just one example of where, excuse me, bigger research projects sometimes come with huge amounts of overhead. I often think of this guy in the background here, Peter Drucker, who is often called the father of the MBA. He was the first person really to look at management science, I think, as an academic discipline. He was a professor in the States, again, only died a couple of decades ago. But it was him that I first got this idea from. He said, small business owners, the mistake that they often make is that when their company is growing, that they don't realize that the overheads in the company are going to grow at a faster rate than the customer facing part of the company. Okay. So anyway, so the other excuse me, preconception that sometimes we have coming into these projects is from the company's point of view. So our collaborators often think that they're skeptical of working with academia. So often I'll tell a company, will say, can we do some collaboration? I'll say, why don't you get an innovation voucher? Because that's going to cost you nothing. We could just look at some stuff here and that'll get the ball rolling. And sometimes they say, they see academics as sort of publication driven. I'm only going to get a report. It's not actually going to tell me anything tangible. And, that's all I'm going to get out of this project. And excuse me, I'll just take a quick drink of water. So, yeah, I mean, just from an academic point of view, that's actually a fair enough thing for those companies to think. I think, there's a New York Times article here, the pandemic claims new victims, prestigious medical journals, where there's been 2 study retractions in 1 month. And it's a good example because obviously the pandemic has, caused riots, obviously, but we have vaccines now. So again, there's a tangible research output out of a lot of these journal articles. The publication isn't the final research output when it comes to vaccines. It's the vaccine itself. But a lot of computing research that I see, in fairness, like from the company's point of view, I can see a lot of work that's done in computing research is kind of publication focused, and the output is some sort of publication at the end of it. And that's not what these SMEs are into at all. So I think it's just interesting. So there's preconceptions on both sides. And it takes a lot of work to get one of these, upfront work that before you agree to work on the project, you'd spend a couple of hours teasing things out with these companies. Okay, so there is that side to it, which, you do have to consider, I suppose. So where do companies go once we do these research projects with SMEs? At the start, I said, look, companies can't really expect in a €5,000 project to get a fully fledged product out at the end of it, something that they could put into production and run in their company. Rather, they usually get some sort of report, okay, but the report is a technical report rather than a publication, and we'll give them the code. So we might develop a Python script or whatever. What's the next steps after that? What's the company going to do? From my point of view, if I don't enjoy the work, or I get to the end of the project and I say, look, I don't have enough time, I mean, I can just walk away, right? That's a downside from the company's point of view. I don't have any skin in the game anymore. But sometimes, so I don't like doing that, and I try to tell the companies ahead of time, look, this is what are you going to do at the end of this? How are you going to take your script off and do some sort of DevOps on it that will get it out into production. So we've had two mechanisms that we've been looking at with some of the SMEs. So one of them is to go back to Enterprise Ireland again and say, look, we have something from these innovation vouchers. There's more work here, there's loads of work. Can you give us a bit more money to do some sort of a collaboration? And they have an innovation partnership program, which has been brilliant. But again, it's turning the small projects into the big research projects. And we have had, all the issues around recruitment, contracts that are more complex, and the companies have to put money into the projects in the innovation partnerships. The headline figure usually on those projects is about 100,000 to 200,000, maybe up to 400,000. They tend to be on the smaller end with SMEs. But we have those. But again, out of those projects, they're essentially like a bigger innovation voucher. You work on something bigger. Again, the output is kind of a research report. So, and like some sort of prototype. The idea is at the end, the company will license technology. Interestingly, just on the cloud front, I just mentioned this, and I'm nearly finished now. In the innovation partnerships with one of the companies, we said, look, how are we going to get your script running in an automated fashion? There were, they had a number of different scripts, and they needed some of them run every day, some of them run every week or every month or whatever, and then some of them need to be triggered on an email arriving or whatever. So what we did was we said, look, let's try AWS Lambda. So we built Lambda functions for each of the scripts that we needed. It made sense because the output of the innovation vouchers was usually just a script. It could just be 20 or 30 lines of Python code, but figuring out that they were the right 20 or 30 lines was the hard part of the research, right? But so we put them in the cloud, and then we could build them into kind of step functions. So you can connect different AWS Lambda functions. So a Lambda function is literally just a function, put it in the cloud. So we could build them up and build a small program with our functions. And then we could use AWS to trigger them on a timer or based on some event or whatever. So AWS has all this infrastructure, and it's brilliant. It is very, very good. When we showed it to the company, they said, whoa, okay, this is great that all of this runs nicely, and it's up there in the cloud. But we're not going to be able to run this when you hand it over to us. There's just no way. This is too complex. And like, in fairness to them, AWS Lambda is, many of the use cases are for people who have huge web applications who like need Lambda functions to run like 1,000 times every second or something like that. They're not really built for these SMEs that only need like periodic sort of running maybe 5 times a day or whatever. So it was probably the wrong solution in any case. But it was interesting to build it for them and learn all about that, and to be able to show it to them and say, look, like rather than me coming and saying, look, putting all this into AWS, it's going to be overkill. If I'd come to them and just said that, I think they would have been skeptical. So we built it, took a little bit of time on one of the projects, we showed it them, and I said, okay, I can see now, this is too complex. And they kind of said, look, maybe even you just stick it on a Raspberry Pi, it'll probably be fine, because at the end of the day, we can call it big data, but what is big data? So anyway, the alternative, and I'll leave you with this. I said there were 2 ways to get out of these innovation vouchers and provide a follow-on for the company. So the first is the innovation partnership. Second is to look at some sort of commercial venture that we could try and spin out of GMIT, and that's what we're trying to look at the moment. So we're in very early days. EI, Enterprise Ireland, have given us money to do a feasibility study in this area to look at. It's very nuanced. Going back to the, what do I actually provide in these research projects? Trying to answer that question is very tricky, and part of the feasibility study, in fairness, is kind of along those lines. EI have been very responsive to. Yeah, you do need to identify that, but I'm not sure we'll always be able to articulate exactly what it is that we're going to provide. It's definitely not infrastructure as a service, right? They're not looking like AWS is there for, providing a solution for follow on from scripts or whatever. But these companies, they can't really get into AWS. It's too complex. It's too much. It's a big sort of beast, and it's too much. So the way I always think of it is, what we're actually looking to do is provide Maths as a service to these companies. And again, it comes back to like, how do we define that? But I think there's something there, and I think there's going to be more and more of these SMEs coming around, where they're not necessarily computing companies, but they are tech savvy in some other industry. And by tech savvy, I don't mean they're just happy with computers. They're able to go into Excel, they're kind of Excel power users, and they're looking to go beyond that now. And, I think this will snowball a little bit. I think there's going to be, a change in the economy maybe in the next 10 years, particularly because if you look at, like, say, even second level, there's now computer science as a subject. So you're going to have these students who are coming into third level, and we'll have to think about that as academics in the provision of our course. Going to be students coming into third level with loads of computing skills. Okay, so anyway, look, I'll leave it there. I've run probably 10 minutes over what I had intended, but not too bad, I suppose. So thanks very much for listening in.
Ian, thanks so much.
Seamus, do I need to send something back your way now?
No, you're fine. You're fine. No, thank you so much. Thanks so much for bringing us through that. It was really interesting insights. I love your idea of maths as a service, as a concept to help those SMEs. It's not something I'd heard before, so it's very interesting. I was also very interesting listening to your comparison between the SMEs and larger companies. that less meetings, less overhead, taking more risks. And I was thinking to my own employer in Genesis, and some of my colleagues who are there longer than I am, have told me stories about that. When they were an SME as Alta Cloud before they got acquired, they were in that mode as an SME. They probably had those less overheads. They could take more calculated risks. Trying to look for that niche product and try and get it out the door. So I can certainly resonate with what you're talking about there. Again, it's really interesting to get that idea of how you're helping SMEs and getting that understanding, I guess, of those SMEs who haven't maybe fully framed the problem that they're looking for versus those that have. So again, I just encourage everyone to get questions in if you've got questions. I probably have loads of them from listening to you. But I guess just a couple, one maybe slightly off topic, Ian, but I'm really interested to get your opinion on it. I mean, you made one really important comment, I thought, through your presentation. You talked about STEM, and you talked about, obviously over the last 12 months, the importance of the science, with what we've seen across the world with the global pandemic. But, the more of that emphasis on the technology, the engineering, and the maths. And then you at the very end of your presentation, you talked about the changes in the academic system in terms of second level curriculum starting to bring on computer sciences. It's something that I think all of us in the Western Seaboard, from all the companies, we all think about a lot, is how do we get particularly more kids into this space, into the engineering and the maths, as well as the sciences. And I suppose particularly how do we get young girls in there as well, because it is predominantly a male dominated area. And I know it's kind of off topic to your discussion, but I would be very interested in your thoughts on that.
No, it's a great question, actually, because I mean, I think a little bit about the fact that all throughout my background, I've been kind of good at maths, right? And that's very unusual. Like, I'm usually a bit embarrassed about it, if I'm honest. Like, it's awkward when you tell people what you do and they're like, maths. It's just something that I was good at when I was younger, probably to the detriment of other areas. But I come from a perspective then that is not the same as most people, So my answer to how to make maths better for the vast majority of people at second level, or project maths, and even trying to bring computer science into the works, it's probably going to be limited, right? But I do think a couple of things. First of all, this whole idea of making maths exciting and bringing it into the real world for people, there's something to it, but that's not the problem. I don't know if I find it exciting, I find it really, really interesting. You kind of get a bug for it or whatever. So I don't really know. I think it's more that the framework around mathematics actually isn't there, because the decision makers often actually don't really like maths themselves, right? I mean, if you went through the list of politicians, they'll probably all say, oh, well, not all of them, but some of them will say, I didn't really like maths, and they're going to be making the decisions. There's always the problem as well. A big problem when I was working in industry was this idea that the chief decision makers in the company actually often weren't computing people, because the companies I worked in, well, I worked in IBM, but when I worked in Aon wasn't really a computer company, it was an insurance company. So a lot of the decisions that we saw on the ground needed to be made from a computing or a data analytics point of view. You didn't have the decision makers on the top who were tech savvy enough to understand the problem. So they'd usually just go, look, just ask the IT person and get the IT manager and we'll just do whatever they say, which is a huge problem from our point of view, because if you come back to that Aon, the segregation between the people who see themselves as the IT department versus the data analysts, the IT department, like if you look at what's happened to HSE, let's not mention the war, but their instinct is to lock everything down. Is to make it more difficult in a way to use your computer or to do something silly with your computer. Whereas the data analysts usually need to be able to be like, oh, actually, I do need that library that I have to install now, or I need to look at this. And they can't wait around 3 days for somebody from IT to come over and install that for them. They need to just be able to do it, okay? Because it might be just a 30-second thing that they do, and they're like, oh, actually, this isn't, I've installed TensorFlow, but actually, I don't think this is the right thing. So like that 3 days I waited was for 30 seconds of me realizing, nah, this isn't right. So, I mean, in terms of getting people interested, I do think sometimes it's actually, getting people into mathematics, it's a huge problem that making maths exciting isn't going to fix. And it's that, how do we get parents to have conversations with their kids where the parent actually understands that, more than just, oh, maths is really important. It's more like, that maths is really important, and here's a few mathsy kind of things to think about. I mean, if you come back to that Bridges of Königsberg problem, like everybody can understand that, and it's kind of interesting.
Yep.
And maybe that can, I don't know, stir something in somebody. So it's very tricky. I don't know what the answer is.
It's not an easy problem to solve, but yeah, I think we'll all keep doing what we can from industry and I guess from academia to try and help. It's especially promoted in second level as well as primary schools. We have a question in from George. He said, Ian, great presentation, and thanks you for it, and especially the focus on SMEs. So he said, can you say a bit more about his work, about how the commercial venture with SMEs might work?
Yeah, thanks, George. Yeah, I mean, that's kind of where the stage we're at. I originally thought, to be honest, that the AWS Lambda stuff would kick off. I thought it was obvious. This is the solution, is that I was creating little Python scripts for these companies that didn't need to be software development, in the sense that there was not really going to be an end user that was not in the company. It was for the company to run themselves. So like all the error checking and making a nice GUI or whatever you want, didn't really need that. But so I thought AWS Lambda was the solution, and it was interesting to see that company's reaction when we built the solution in AWS Lambda for them. They said it's too complex. Now maybe there's some solution in AWS Lambda or something similar that is a little less, I don't know, convoluted, I suppose. Maybe not. I mean, maybe it can't be. So I think the commercial venture would look, again, like we need to stay away from thinking of it as just infrastructure as a service. It's more, there's kind of two aspects to it. I mean, one is that maybe you can provide some sort of a consultancy side to things. Now, that's not a great, when funding bodies hear consultancy work, they think, well, that's limited to the number of consultants that you have, so it doesn't scale very, very well. I mean, I don't buy into that too much, but whatever. Like, so when you're trying to provide maths as a service, how do you get the human out of the equation? How do you get that, oh, and then I just do this as a human part out of your workflow in data analytics? So I think the solution there is to actually provide some sort of framework where you pick, you look at the industries that you've been working in, say on innovation vouchers, and you pick 5 or 6 common tasks, some way of plugging different scripts together, where in the middle there's a nice big generic part that all of the companies are going to want to use, and then provide that as a service maybe. So maybe some combination of the two of those, where you have these, they're more than just software scripts, generic sort of, regular analyses. They're like fairly in-depth, maybe machine learning models or something like that you've developed, that then you are providing in some way, shape. It doesn't necessarily need to be a big infrastructural thing, because often these companies will be happy if they can sort of automated enough, but also go in and have a look at it. So in that sense, AWS Lambda is probably overkill for it. So to be honest, George, I don't have a brilliant answer for you, but that's what we're working on, I suppose, you know.
So we're nearly out of time. I'm going to try and sneak in one. I'll get you maybe 10 seconds if you can, or as quick as you can. Just the last question from Patty. He said, do you think there's a need for maths and computing professionals to step out from behind the cloud? Would you think that there's a comfort with the expertise and people may complain a lot about bad decisions, but don't necessarily want to take the risk in getting involved?
Yeah, I like something, maybe it's not quite the answer to your question, but one thing I do think a lot about is the fact that maybe the old ideas that we have in academia of the departments that we have, like having a separate maths department to a separate computer science department, or maybe we need another department that isn't either of those things, but is sort of related to it. I don't know, like there's all these old like precedents of structures that exist in third level that, like if you look at the higher diploma in data analytics, it would fit into a business department, it would fit into a computing department, fit into a mathematics department. And indeed, like there are programs with that title that are very different programs as well. So I think there is a change coming. It's probably going to be gradual. Like I don't know where I fit. My PhD is in mathematics, but everything I've done since is kind of computing work. So like, you know, I often think if I applied for a job in some computer science department elsewhere, they'd probably say, sure, you don't have a PhD in computer science, your PhD is in mathematics. Whereas if I applied to a maths department, they'd probably say, well, all your work hasn't been in mathematics since you left your PhD. So I don't know where I fit. So
yeah, and I guess that whole academic world is changing. I guess even if looking at the new postgraduate in UL, which was run out of the Department of it was the economics, partnered with Stripe and other business vendors. So I think those lines are starting to blur. I guess as opposed to those traditional faculties that you would have had going back.
And look, I'll just leave you with this because I know you're running out of time. But like the plan is for GMIT, IT Sligo, and Letterkenny IT to become a technological university, which will probably happen in the next year. We've a good opportunity here to, I mean, we're not going to go to change the world, but we could focus on SMEs and we could look at these old structures and say, well, it makes sense here. Like we could be a bit more flexible and dynamic because we don't come with 200 years of baggage of old, you know, systems and like there's no problem with them. It's just that we have an opportunity to provide something slightly different, I think.
Yeah, that's very exciting time. Listen, Ian, thank you so much for taking the time to join us at AtlanTec Festival 2021. We wish you all the very best with the commercial venture and keep us up to date on how that's going. Just for everybody else, just to let you know, AtlanTec, it's still ongoing. There's more talks happening and lots of great panel discussions. So even later today, we've got the team from Man and Drones talking to us about their business plan. So that's happening later on today. And tomorrow, then there's some great insights, especially I'm looking forward to hearing from Professor Jim Duggan about